Okay, so let's go over number 77 up here on the board today. Okay, again, it's electrolysis of this molten metal chloride, MCl3, using a current of 6.450 amperes for 1397 seconds. Deposits 1.41 grams of the metal at the cathode. What is the metal? How do you figure this out now? Yes, Sandra. Okay. Okay, hold on a second. 60 seconds. 606.50. What is an ampere then? Is an ampere just an ampere per second? Coulomb per second, right? One thing to remember, an ampere in this case, this kind of problem is going to be a coulomb per second, right? So this is going to be a coulomb per second. 908 and to the third coulombs. We're going to divide it by 96.485 coulombs per mole, right? Or we want to divide it. We don't want to multiply it though. Why do we want to divide it in this case? Like coulombs cancel out, so we want to divide it by this number in this case. But how do you find the molar mass of the metal in this case? What's the next conversion we need to solve this problem? Moles of metal versus moles of electrons, right? So how many moles of metal do they have their moles of electron then? How do you figure that out? Okay, you have metal chloride, right? Let's figure this out. You have metal chloride. So you have MCl3. Which should break down into M plus 3 Cl minus. What will the charge of the metal be in this case? Plus 3, right? Okay. So in this case, so the charge of metal will be plus 3, right? So how many electrons does it take to react with 1 mole of metal then? 3 electrons, right? So you have metal, 3 plus 3 electrons. We'll go to molten metal. We'll go to metal to cathode. Does that make sense? So it means for every 1 mole of electrons, every 3 mole of electrons, you get 1 mole of metal. Okay. Yes, Stephen.
They retain their shape.
They retain their shape, right? Very good. Any other properties you can think of? Are they very compressible?
No.
What do I mean by compressibility? What do I mean by that? Ability to be compressed. That's a good answer, right? So solids can't be compressed, but can gases be compressed? Yes. So solids are not compressible. But gases are highly compressible. What about density? Do solids have high density or low density?
Same density as.
Same density as what? I'm sorry, David. What did you say?
Usually the same density.
Same density as what? Oh. They sometimes say same density as liquid, but they pretty much have high density, right?
Yeah.
Higher density than gases, right? So
More mass per volume.
right, more mass per volume, got it. Higher density. I won't say gases will be. Okay. What about are they rigid or are they not rigid? They're pretty rigid, right? So it's pretty easy. Percent. A solid one. They're both solids. They're both solids. This is more order, right? This is a crystalline solid. What could this solid be then? Say for this solid. Amorphous, right? No, we have two different solids here. This is a crystalline solid. This is amorphous. Did I spell it wrong? I probably spelled it wrong doing that. I did try though. How do you spell amorphous? How do you spell amorphous? A-M-O-R, I'm asking for A in this case. How many atoms are in A, right? Right, you should keep it as thick like C is, right? How many corners of this cell do we have? How many corners do we have? 8, right? So we have 8, 1/8 of an atom, right? This is 1/8. This transfer is 1/8 of the atom, right? 1/8 times how many corners are there? How many corners are there in a 8? So there's one atom in a simple cubic, right? How many atoms are in a body-centered cubic? 2, right? How do you think of 2 there, Diana? Uh-huh. One in the center, right? So there's 1, 2, and 4. So why is this a molecular solid? What do I mean by molecular solid? It's very good. It's a good example. What happens to covalent bonding? Electrons are shared. Ionic bonding has an ionic bonding. Sort of transfer to the other element. Very good. Electrons are lost, right? This case, the solid will lose its electrons to chlorine and it'll form NaCl. We want to balance it or whatever. That's how it's balanced. Does that make sense? Ever have figured that out? Covalent network solid. Anyone give me an example of a covalent network solid? On your sheet right there.
SiO2.
SiO2, right? What's this silicate, right? What's another example of a covalent network? I actually have one on right now. I actually have a covalent network solid on my body right now. What is it? Diamond, right? I have a diamond on my finger. What am I about insulator? Insulator, sorry. What am I about insulator? I was going to say, what am I about insulator?
You said they're soft.
They're soft, right?
How can diamond?
Diamond is not a molecular solid, now is it? Molecular solids are like H2O, noble gases, halogens, things like this. Molecular solids, they're insulators. What does insulator mean? Steve, I don't know. What does insulator mean?
It does not conduct electricity.
Say that louder. What does insulator mean one more time?
It does not conduct electricity.
Very good. Does not conduct electricity. That's what insulator means. Does not conduct electricity. Thank you.
Insulator?
What did you say? I'm sorry. Okay. What about a metallic solid? Is metallic solid, will that conduct electricity, you think?
Yes.
Yeah.
Okay, why will that conduct electricity, you think?
Because the whole thing has electrons.
Very good. Say it louder, David. Why will metallic solid conduct electricity? Say it louder, David.
Because there's electrons going throughout.
Right. Has anyone ever seen salt melt? Has anyone ever seen salt melt? Has anyone ever seen diamond melt? No. Here's why these two things have very high melting points. All right, what kind of solid is that? Covalent what? Covalent network, right? In the book, I think they just call them network solids. So just worry about it. They call them network solids in the book. In the book, there's network solids. What about letter B? What is that? Ionic, right? What about letter C? Molecular, right? It's water, molecular solid. What if I had magnesium up there? What would that kind of solid be? Magnesium. Has anyone ever heard of a superconductor before?
Something that conducts without resistance.
Exactly right. You got something conducts without resistance. How does it conduct without resistance? Anyone know how to conduct without resistance?
How? Or what?
How? How?
When the bosons and compensate electrons flow in comparison to fluid.
Right. It flows through, right? So silicon is a superconductor. What kind of solid is silicon made?